Hi, everyone. My name is Scott Schmidt. I'm the Senior Drinking Water Analyst in the Operator Training and Certification Program. If any of you have taken cross connection in the last 5-ish years with the state, my name is likely floated across your guys' desk at some point, or you've seen my name. Or some of you are maybe students of mine in the last chemistries or chlorination and fluoridation class that we've held since the beginning of January. So I'm very familiar with cross connections. I've been doing this for, like I said, about 5 years now with teaching this class for the state. And we're going to be going over the basic cross connections, what the devices and assemblies are, information about them. And then we'll be talking about some commonly asked questions that we get from you operators and you who work at municipalities of things we should be doing. So that's what we plan to do today. Like Matt had said, there'll be some poll questions and stuff. And I'm being joined here by one of our district engineers who is out of the Cadillac district office. His name's his technical name is Robert Weir, but he goes by Bob Weir. He's been around for a number of years now. Bob's a great guy, very experienced in this knowledge, and has taught this, I think 3 years now too. So, and he's involved with the plumbing board and so on and so forth, and any changes that go on with that. So he'll be able to answer those questions too throughout some time today. If there are some that you guys have that we can't, that I can't necessarily answer, and then tomorrow I will be assisting with answering questions while Bob is presenting, kind of thing. So with that being said, Matt, let's go ahead and get things started with the first poll question, and we'll get things rolling with the slideshow.
All right, thank you, Scott. We'll go ahead and fire up this first poll question. And we just want to know how many people are viewing this webinar on the device you are logged in with. So if you can take a moment to answer that. As far as handouts go, those were emailed to you last week, and they were also emailed, or at least to registered attendees last week and this morning. That email would have come from Joel Roseberry, who works at Eagle, and that's got a copy of all the presentations in it. All right, so we are up over 90%. I'm going to let this run for about another 15 seconds, and then we will close it out. Remember, if you are looking to get continuing education credits, then you do need to answer the poll questions. If you're having technical issues, please submit those using the Q&A. I do notice that we have one person calling in. And if you are calling in on the telephone, you are not going to be able to participate in the poll questions using your phone. So unfortunately, you will not get credit if that is the only way that you are participating. So I'm going to go ahead and close this. Looks like we've got a few people that are struggling with the poll question. Remember that Zoom needs to be your active window, needs to be your primary window on your desktop. If you're multitasking or on a different screen, you may miss it, but you do need to come back to the Zoom screen on your computer. On the toolbar, there's a little Zoom icon. And once you click on that, that should make Zoom your primary window. So I am going to go ahead and end this poll. Looks like got about 93% that were able to complete it. So I'm going to go ahead and end that, turn it back to you, Scott.
All right, without further ado, let's go ahead and get started with this, all right? Because we'll be doing a little bit, take a short 5-minute break, and then we'll do the next PowerPoint, and then we'll see where we wind up with time, all right? So, gonna start the slideshow. Okay, so as far as this goes, this PowerPoint that we're going to cover right now, because a lot of people, one of the questions, maybe Matt in the poll coming up, is to ask how many people are here for CECs versus how many people are here because they're going to be taking a new examination or so on and so forth. So as far as the information goes that you will see kind of in examinations, I'm going to tell you to pay close attention to this slideshow and kind of the next slideshow, okay? As far as the stuff that's really good for how to run a program and so on and so forth too, this knowledge is also good for that, because you need to know what the devices are, what the assemblies are, the different definitions of things, commonly asked questions of, high hazards, low hazards, so on and so forth, because that is all an integral part of running a cross connection control program at a city or municipality, right? So let's go ahead and get started. So what is a cross connection? All right. A cross connection is an arrangement or appurtenance of pipes that connect a potable source of water to a non-potable source of water. All right. So what do we consider a non-potable source? We consider a non-potable source anything beyond a meter. All right, typically, or anything beyond a service connection. And the reason we consider that non-potable is because we do not know or physically know the activities that are occurring within that residence, that commercial building, or that industrial building. Do you, as a public water supply, have the right to go in there and conduct an inspection? That's kind of a fine line. Yes and no is the answer to that question. Right. So you do have the right up to the meter to have allowable access to, conduct activities with the meter, so on and so forth. But you got to work hand in hand and be in partnerships with your either residents or your industrial customers or commercial customers, and be on a good kind of common footing with them. That, look, you're just trying to protect the water system and possibly their employees. So inspections are something that we'll talk a little bit about too, that need to be conducted annually or triannually or so on and so forth. All right. So why are cross connections such a concern? The number one main cause for concern is the public health hazard that a cross connection poses. Well, for the fact that it's a potable to a non-potable source, meaning we don't know what's going on in that residence, so on and so forth, there's a lot of opportunity for sickness, illness, or even death to occur due to backflow events. All right. If you had to guess in the nationwide percentage of this, right? What percentage of all sicknesses or illnesses or deaths, hopefully not deaths, but sicknesses and illnesses that are caused by drinking public water are caused by cross connections? All right. Just think to yourself, give me a percent. All right. Well, the thing about it is roughly about 70% of all illnesses and sicknesses that occur during because of drinking water are due to cross connection issues. All right. So the thing about that is someone, right? Okay. Yeah. It's roughly about 70% on that. So that's why it's a huge concern. Some can be worse than others. And the other thing that's a big concern is how many of those go unreported. Okay. And what I mean by that is if you have cross connection, let's say a water main break occurs out in my street, and I have one of those, I have no backflow preventer on my garden hose connection like I should, or my hose bib or any of that. And I have like a Miracle Grow can attached. That's like a water sprinkler thing. Well, due to a couple things we're going to talk about, well, that could backflow into my service line and maybe to a couple of my neighbors, right? And if you ingest that, or it might be just to my household, but the thing is if anyone in my household ingests that little bit of fertilizer, sure, it ain't going to kill them, but drinking fertilizer is not good for you. And it would make you a little bit sick for a few days. It might give you upset stomach or, indigestion or any of that kind of stuff. And with that occurring, that you're not going to know. Because a lot of times if you get a stomach ache for a couple of days or have indigestion or something, what do you chalk that up to? Oh, something I ate. You know what I'm saying? So for the fact that that could occur, a lot of cross connection issues go unreported, just so you know. Trying to keep this stuff out so it keeps that down, drives me up the wall. All right. So there are laws and rules and guidance that guide us. Part 14 of the Safe Drinking Water Act, which is Public Act 399 of 1976, give public water supplies and require them to implement an ordinance for cross connections. And the ordinance typically goes in a couple routes. It involves inspections, it involves testing, and then it also involves looking for and eliminating cross connections. All right. I know that we talk about eliminating cross connections, but I'm going to be honest with you. there are just some applications you cannot eliminate the cross connection. So that's the type of connection that we have to make sure that we're staying actively on testing and inspecting. All right. So there are guidance with the Michigan Plumbing Code, and then we have what's called the DEQ cross connection manual. And this is still the thing that we reference a lot because it's a very good document. I mean, yes, it's been a number of years since it was updated. Last time it was updated, I know on the book itself, I think it says 08, but it was updated in like 2014. All right. I do know that for a fact because I worked with the guy who updated it. So the date was not changed for some reason. So it was updated in like 2014, and we updated it when the cross connection rules were proposed to be changed due to inspection frequencies when we actually put that in the act. So the rules manual was updated at that point too. So some of the terms we're going to talk about backflow and the two things subjugated under that, which are back pressure and back siphonage. Then we'll talk about high hazards and low hazards, testable versus non-testable, or other key terms such as assembling devices. And then we'll talk about inspections versus testing. All right. So backflow. Backflow is the undesirable reversal of flow within a water system or distribution supply. It occurs under two things. It occurs under back pressure, back siphonage, and sometimes it can be a combination of both, just so you know. So what's the difference between them? All right, so one thing here that I want to point out, and we were unaware of for a while, is that here you can see the water's coming into the water main. It's 80 PSI. And the reason that that's at 80 PSI is because the maximum pressure, residential pressure going in is supposed to be 80 PSI or lower. Just FYI, that's the maximum residential pressure according to plumbing code from 2016. So as you can see, the main's at 80 PSI. Here, it's going in at 65 PSI. And then we have a water main break. That water main break is going to create what we call zero pressure, okay? And zero pressure, this is a commonality. A lot of people think when something is zero pressure and that the line would be at 65 PSI going to the house, that this is back pressure. And that's actually not true, okay? This is known as back siphonage. And the reason it's known as back siphonage is because for the fact that zero pressure also refers to creating a vacuum, okay? Back siphonage is a vacuum caused by zero pressure, all right? So that backflow event that we're occurring here, the water's going to run out of the house, and then it's going to come out here. We know that this is not supposed to happen. You don't hit a hydrant, it's supposed to blow out water. This is a Hollywood picture, just so we're all aware, because this would break away the shackle and it would close the bottom valve so that it wouldn't gush water. But anyway, this is a backflow event as back siphonage. But remember the example that I was talking about? If I had a Miracle-Gro can, let's say there's a Miracle-Gro can here on the garden hose, it might only affect my house, the service, or it might come out here and go into a couple service lines once this is fixed and goes and is recharged with pressure. So that's why cross connections are an issue. Now, the reversal of normal flow caused by something creating a higher pressure, okay? So there are a couple different examples that are the primary causes. If there is a boiler or some sort of booster pump within the house due to an irrigation system, or it's a very large, expansive house, mansions are going to have booster pumps in them that push water pressure throughout it a lot of times. Those pumps create a pressure. Boiler creates pressures because it boils the water, and pumps create pressure because they're a pump. Those will create higher situations of higher pressure within a house, a business, an industry than that of the water system. Most water systems in Michigan, they run anywhere from 50 to 65 PSI. It's not to say that there isn't higher ones out there, okay? I'm not saying that. There are, but 50 to 70 is like the sweet spot range that most water systems in Michigan run. And with that being said, it's very likely that a pump or a boiler could easily surpass that with PSI. So if you have a chemically treated boiler or a chemically treated lawn irrigation system that has a booster pump on it, it is very likely that the water could be pushed out to the system because of a higher pressure. That's why backflow preventers are required on these things. All right. So here's just an example again of how boilers heat up water. They boil water. So that pressure will vastly exceed most likely that of the water system. And a lot of boilers are treated with scaling agents so that they don't have a buildup of calcium and stuff within the boiler tank itself. Those scaling agents or anti-corrosive agents are not good for human consumption. It's okay if it's used in a heat exchange type system and so on and so forth, but it could backflow to the water system, and that stuff's not good for people to drink. Backsiphonage, again, I kind of already hinted at with that picture and showing you what backflow is. That backsiphonage is the reversal of flow due to a vacuum or partial vacuum. All right. There's two main reasons for that. The two main reasons for that are water main breaks, because they create a zero pressure or 0 psi, which creates a vacuum or partial vacuum, and then a fire demand. What happens when a fire truck hooks to a thing, a fire hydrant? That is a great big vacuum on that truck, is it not? It's a pump sucking out water from the water system. Okay. So just so you know, during fire emergencies, the minimum residential pressure is allowed to drop to 20 psi by, it's not allowed to drop below 20 psi, but under fire emergency, minimum residential pressure for water system can drop to 20 psi. All right. So here you go. Here's water main break. A lot of the water systems in my local area here in Lansing, I've had Lansing, Jackson, Saginaw. For a few, I've heard there's been a few big water main breaks this last week because of the heating and like, you know, the 55 degrees days went from being frozen ground to 55 and like snap your fingers. So there's been a few water main breaks the last couple of weeks. And then firefighting, right? I mean, look at all this thing's hooked directly to it. It's a giant pump. So ask yourself real quick, a self check, is this back siphonage or is this back pressure? The real thing. How about back siphonage, right? He's sucking, vacuum or suction is back siphonage. Okay, so high hazard and low hazard, we use the words contaminant and pollutant. And the thing about it is, the reason that high hazard is considered a contaminant is it creates acute health conditions. And what I mean by acute health conditions, it causes immediate health risk. So that's one thing when you're doing inspections or looking at things, you can pose the question to yourself. Does what's going on in this facility or what's going on in this water system or this house or any of this, will it immediately make someone sick within a short time frame? I'm saying, you know, within a 72-hour time frame, would it make them sick, right? Well, if it does or poses some sort of health risk that can create a very bad scenario health-wise, typically anything that's chemical is considered high hazard, okay? Anything that involves chemicals, even dishwashers, is considered a high hazard, okay? And then with non-health hazards, they're considered a low hazard, or we call them pollutant. I like to use a scenario that I use 3 questions for. It's called aesthetics. Non-health hazards or low hazards are considered aesthetics. It looks bad, it smells bad, or it tastes bad. Okay, those are the 3 things that I tell myself. Does it look bad? Does it taste bad? And does it smell bad? All right, because some of us have an affinity for drinking iron water. Some of us do not. We live in Michigan. There's lots of wells all over. And most likely 90% of the people on this call today or webinar today have been to someone's house or family member's house where they drank the water and go, oh, tastes like metal. Well, it's because it's high in iron, right? Well, iron has no health risks known to it. So it don't taste good. It definitely doesn't look good because it leaves rust stains on stuff. But we consider something like iron a low health hazard because it doesn't hurt anything. It doesn't look good and it doesn't, it doesn't look good and doesn't taste good. But in the grand scheme of things, there's no known health risk with ingesting iron in well water. So that's why it's considered a low hazard. Or I just want to give everyone an example of that because people often go, well, what's the difference? So here are some examples of this. And we did go ahead and update this because there was a lot of missing ones under high hazard. So your typical high hazards are wastewater treatment plants. That's kind of given, right? Funeral homes. Yes, funeral homes are definitely a high hazard, and that's because they use aspirators, which are hooked to water systems to embalm bodies. All right. Dentist's office, because of just the way they sanitize their equipment, their drains, and all that stuff. Car washes, plating and chemical plants, laboratories, marinas, hospitals, restaurants, and taverns, mainly because of the dishwasher solutions. Oops, sorry, clicked. Mainly because of dishwashers and stuff like that. Chemically treated boilers. We talked about this, right? Your high pressure boilers are often chemically treated with anti-scaling agents and anti-corrosion things. Chemically treated lawn irrigation systems. I'm not going to mention names, but I know of a lawn irrigation system in East Lansing that the guy sprays, he hooks some treatment into his water system for his lawn irrigation. He sprays it on it. It's a growth suppressant hormone for his lawn. So like if he goes on vacation for 2 or 3 weeks, he hooks that in, sprays it all over his lawn. The grass stays green, but it doesn't grow. It stunts its growth, so to speak. It like puts it in a dormant stage, but keeps it green. So you can't tell me that's not chemically treated, right? Fire suppression additives. All right. A lot of times different fire suppression systems, especially in restaurants, will have different additives, right? If it's the one that's over the fryers, it's going to have an additive for grease fires and so on and so forth. And then sumps. Sumps have been considered a high hazard now because everyone and their brother is now installing what's called the water assisted sump pumps, which is a sump pump that runs on the water turning from the water system because, the water is always supposed to be flowing in municipalities because of backup power. So a water assisted sump pump, which is hooked to the water system and runs off the water system, is also put in a sump. Those are high hazards. Those require an RPZ. So that is something that you as cities need to start looking for is the water assisted sump pumps. They are becoming more and more and more common in these houses, and they're hooked directly to your water system. And a lot of times they get hooked in by either the homeowner or some fly-by-night plumber, and they don't properly protect those and protect the water system. So that's one of the biggest things that you guys, as doing inspections, need to look for in residential. Okay. Typical low hazards. You'll see pictures of his water assisted sump pumps and what they look like tomorrow with Bob. Okay. Just giving you a heads up. So low hazards are offices, fire suppression systems with no additives, though I would argue that it depends on how long the fire suppression system hasn't been flushed, in my opinion, because they flushed Constitution Hall where Eagle is at when I first started, essentially, and the water came out of there like black and stinky, which means there's anaerobic crap going on, which that's not drinkable in my opinion, but whatever. And then low pressure untreated boilers. All right. So testable versus non-testable. So there's a distinct term and terminology when talking about backflow preventers. All right. If someone is referencing something that is what we consider an assembly, assemblies are considered testable. All right. What's this question? Testable assemblies. Okay, so there are 3 of them that are considered assemblies. They are mechanical working devices. They have test ports on them that allow you to isolate the valves and test the pressures to ensure that they are still in proper working order. Okay, they are what we would call an RPZ, a reduced pressure principal backflow preventer is its technical name, a DV double check valve assembly, and pressure vacuum breaker are the 3 testable assemblies. Then there are non-testable devices. And the thing is, these are non-testable and they are used in the industry as reference as devices. All right. So assemblies are testable, devices are non-testable, meaning they don't have test ports. They're typically not mechanical. in nature, but they have their drawbacks. And the two main ones are an atmospheric vacuum breaker, a hose bib vacuum breaker, and then a vented double check valve assembly. So just so we're aware, the vented double check valve assemblies come in a couple different natures, and I think we see examples of those here in a second. So here's testable. So testable, you see these test ports here. What these are located in the areas between the different valves within this that allow the tester to isolate them and be able to check the pressures to make sure they're in proper working order. And this is considered, what these are examples of atmospheric vacuum breakers here. All right, as you can see, there's no test ports on this thing. And these would what you would see typically on a couple different areas. These are looking at these ones. I see these on dishwashing sinks or tub sinks at restaurants, or you see these on lab sinks typically too, something like that. All right. So inspections versus testing. So we got to be really clear on this. All right. First off, inspections can be done by anyone. All right. They can be done by municipal, they can be done by a contractor. So typically these are the people who are going to be going out to businesses, commercials, industries, and also residential. So with residential, you got to be careful. The two most common places you're going to see a residential is basically if you're conducting a residential inspection, there's really a couple only places you got to see. And that's typically a basement or where the area of the water meter coming in is, and the outside perimeter of the house. And the reason for that is the outside perimeter of the house is where you're going to most often see your lawn irrigation system connections, and you're going to see your backflow preventers out there. Or if it's something internal, you're going to see it most likely where the water service line comes into the house, which is in the basement. You do not need to be sneaking around houses and opening every single closet door and looking at every single thing, because you don't want to give the intention that you're trying to incriminate them for anything. You know, you're there just trying to enforce your ordinance, inspect the residence, looking at like the heat system, which is usually the basement too, where the water line comes in, and the outside perimeter of the house. And that's usually about it. You don't need to be going everywhere. Now in industrial, they don't have to show you everything. Do you have the right to see right up to right around the water meter? Yeah, sure. But it's really a good idea to have good working intentions with your industrial customers, because you could be, with a concept we'll talk about a little bit later at the end of this slide, so you could be saving people's lives within that industrial building. So inspections, they're going to have water lines running everywhere. So it's going to be hard sometimes to conduct it. But you might be able to also ask them for blueprints of the industry and just show you. They might have a map that shows where all their cross connection assemblies or devices are located within it. All right. So now testing. Back before all this stuff, before rule changes, in order to test devices or test assemblies, in order to test assemblies, you needed to be a licensed plumber. Okay, that has changed. There is a certification offered by ASSE. Okay, you can become a certified backflow tester, and it's ASSE 5110 certification. Okay, you can find in licensed inspectors on their website. Go to ASSE's website and look up licensed testers for your assemblies. Now, Michigan does not recognize in industrial and commercial settings, a backflow assembly cannot be repaired by anyone but a licensed plumber. We do not recognize the ASSE repair certification. Okay, just so we're aware on that. But testing has to be done by an ASSE 5110 certified tester. Doesn't matter. Sometimes those people are not licensed plumbers and they don't have to be. Okay, so let's talk about the 5 means of preventing backflow. There are 5 different things between devices and assemblies that we often use. Did you put the... Oh, it is. Okay, well, until that time that I know that it is, it's still licensed plumber, right? So There's air gap separation, the reduced pressure principal assembly, what we call an RPZ, which is what I'm going to be calling it from now on, double check valve assembly, pressure vacuum breaker, and atmospheric vacuum breaker. All right. So the very first thing we're going to talk about is an air gap. So an air gap is exactly what it sounds like. An air gap is a physical separation of the water system to the water where it's going, the non-potable source. There's a disconnection between potable and non-potable. It's a physical air gap. And we have a couple general rules of thumbs, okay? First off, it does not have to be any larger than 1 foot of physical separation. And the reason for that is the surface tension of water, no matter how big the container is, the surface tension will never be able to create that mushroom effect, unquote, on overfilling a thing over a 1 foot gap. All right. The other rule of thumb that we typically use for an air gap is the gap must be at least 2 times the diameter of a discharge pipe. So let me ask you real quick. If I have a 3-inch pipe discharging to a basin or something, I don't know, let's just say a basin. If it's 3-inch pipe, how big should the air gap be? Just ask yourself that real quick. It has to be 2 times the diameter of it. So if it's a 3-inch pipe, that means the air gap needs to be at least 6 inches. Does that make sense? That's the general rule of thumb with an air gap, okay? So here's some examples of air gaps. Sinks are typically an air gap, all right? They have to be over the flood rim by at least 2 inches, or at least 2 times the diameter over the flood rim of the sink, in quotes. Here's an air gap in like a day tank for chemical feed. As you can see, it's being filled. There's a big air gap there, definitely over a thing. And then here's an air gap to a drainage to a drainage basin that you see these typically in like commercial sinks and commercial kitchens. And you can see that this one's cut at an angle. And we typically recommend, if you can, cut the pipe at an angle, because what that doesn't allow is it doesn't allow the water to create that mushroom effect off the bottom. It breaks the tension of it. It discharges all the water by creating allows air up into it better. So here's some air gap devices. So what we have here is we have a couple different devices that you see. This is a catch funnel on the bottom of an RPZ. We'll talk about why that's there in a second. Then you see this. Well, what this is this is an air gap device. You can't see behind here, but there's an air gap here. And the air gap is, this is like a chemical mixing thing for like mop bucket solutions that you can see inside those type of chemical feeders for making mop buckets. You see them at restaurants for making like different your washing stations for like bar glasses. You got to have dish soap, chlorine, water, whatever, something like that. And it's a chemical mixer thing. If you open the front of it, you will often see these air gap devices like these two here, this one and this one. You have your chemical line coming in, the water line comes from the top, but there's an air gap here physically that separate them so that they don't ever backflow into the water. All right. Bob will talk about that stuff tomorrow, or you'll see more pictures of them tomorrow. So here's an RPZ, or reduced pressure principal backflow preventer assembly. Told you it's got a long name. RPZ. So an RPZ is a mechanical device. All right. The thing about it is RPZs, they are a little bit different than everything else. RPZ is the quote unquote gold standard for backflow preventers. All right. And the reason it's considered the gold standard is because it protects you against everything, though it is a mechanical device. So an air gap never fails because it's a physical separation. It's not a physical device or a mechanical device like this. But if you think about it, air gap applications aren't totally applicable in a lot of situations. So how does an RPZ work? So an RPZ works under normal flow. You have the water line coming. It shouldn't be 800 PSI. But hey, just bear with me. It's 100 PSI. So how it works is the water comes in and then it comes down in here to what's called the relief port. That's what this thing is here on the bottom of this one and this one. These are called relief ports. So it comes down, fills the relief port, and it shuts. And what it does is after it shuts the relief port, it fills the chamber between the two different check valves here, and it opens it. And then this opening of the check valve, and then it opens the second one, and the water flows through in that fashion. And when it does open this check valve here, there is a 5 psi difference loss across an RPZ. Okay. That's just kind of an industry standard. It's a 5 psi loss. And to be honest with you, the law, oh man, I keep doing stupid mouse. The loss occurs on the first check valve, just so we're aware. The second check valve has very little weight. So all of the pressure loss is due to the very first check valve. The second check valve in here, you could push open just real easy with a finger. You know, it's pretty easy to do. It has not much pressure against it. So how it works. Relief ports, a lot of times if there's something happens to the upstream side of here, there's a loss of pressure, the check valves slam down because of back pressure. They slam down and close. And if something happens that lodges in the second check valve, the relief port will open and empty this chamber in between the two check valves. And it could possibly, not saying it will, but it could possibly drain an entire building or entire house's water out that relief port. So wherever this thing is, it could be just dumping water all over. Now, that's why there was a funnel catch on that picture we saw a while back, was because if these things go to dump water out, which they always do when they come into service, an RPZ, when it comes into service, always dumps a little water. I'm not saying it's like a geyser, but it will dump water. When it dumps some of the water, you want it to go somewhere. You don't want to just go all over the floor because it'd be a slip hazard or so on and so forth, right? So you want it to kind of be directed, and that's why there was a catch funnel on the bottom of one of them. All right, as you can see here, here's a catch funnel here off the relief port. Okay, so RPZs, the reason I said they were the gold standard is because they are for back pressure, they are for backsiphonage, they are for low hazard, and they are also for high hazard. Okay, these things are very costly though. RPZs are very close to $1,000 an inch for application. Okay, meaning by the time you divide the device or assembly and then you have it installed, it is very near $1,000 an inch right now in the industry. I know it's not quite that expensive, but it's getting there. It's very close. I do believe I just heard within the last 6 months that someone was quoted just shy of $900 to install 1 inch. So it's very near getting close to $1,000 an inch. These things are very costly. All right. So I'm just giving you heads up. These are very costly. Are they the gold standard? Yes, but they are very costly. All right. So some installation recommendations is they should always be downstream from the meter. Because I told you, as these come into service, they dump water, right? Well, should the cities be footing the bill for some dumped water? No, probably not. So we recommend they be installed downstream for the meter. They must be installed above the flood area or above grade, okay? And the reason for this is there's a relief port there. And if you remember how it filled up like this, it fills up from the upstream side. This is the city water coming into this. So if that relief port is exposed to an area it could flood, it could easily backfeed or become a cross connection into the water system, okay? You should provide adequate room and testing for repair and maintenance on these things. If they are testing them, they have to hook these hose meters up and stuff between the different relief ports, and they need to have access to them. I'm going to just give you fair warning. Anyone who has not done an industrial inspection yet, or is going to be getting a large industrial building within their city and they're going to do an inspection on it, most of them are in the ceiling. Okay. I'm just telling you, like these giant GM buildings and stuff that you see around in Lansing or large Ford building, large industrial buildings, the water is an afterthought. They build the building first and then run the water. Well, the easiest way to run the water when the building's already built is where? In the ceiling. Okay. I'm just giving you heads up that be ready for some neck massages. If you're doing inspections, you're going to need them because you're going to be looking up the whole day looking for them. So just giving you heads up. Okay. They can be installed horizontally and vertically. They can be installed with that, but I will tell you that specific RPZs are meant for specific types of installation. All right. They make ones for vertical installation and they make ones for horizontal installation. All right. Typically, if you can install them at waist height away from a wall, that's best because it's easy to access, it's easy to get to. They need to be protecting from vandalism, flooding, and in Michigan, freezing. Though this winter, this would be arguable. We haven't had that many cold days, right? So in warm climates, you see them like this. I seen these all the time when I was working in Houston. I seen the green boxes with these over. And Mackinac Island actually has meters and RPZs like this because they just go and remove them every spring and every fall and stuff like that. And then reinstall them. But cold climates, you'll typically, if you see them outside the home, they're going to be in an insulated box. Oops. And then if they're in the interior, we highly recommend a catch to direct any water that may spill out from underneath it or from this relief port to a drainage basin or drainage area so that it's not on the floor. So here's some pictures of some installations. You know, does this look like a good one? Well, I'm looking down at it. This bucket looks like it's catching water draining from somewhere. It's right up against the wall. It's just horrible. It's down in a pit or something like that. Then you have this one. This is a ceiling right here, and it's up above a big pipe in the ceiling. Or how about this one? What's this right here? That's light. And then you got a couple other things going on here. This pipe is hard plumbed to the relief port, and it's not a catch funnel like it should be. It's in the ceiling with all this piping. I feel bad for the guy who has got to go up there and test that thing. Luckily, it's not me. So how about this? Does this look like an approved installation, you know? Well, you know, it might get flooded. It might not get flooded. You know, it's hard to say. Looks like we have a drain here, you know, but heaven forbid, you know, a leaf might fall in there and plug the drain, right? So this is a bad installation. And then the other thing you see here is look at this. And all the pictures I've showed you of RPZs, have you seen one with pressure gauges on it? Well, yeah, sure. Just rip the relief port out and put a pressure gauge in there, and we can check ourselves if the pressure's good or bad. So, I don't know. They're supposed to be random, David. Just so you know. All right. And then the RPZ discharge or relief ports, right? We should have a catch funnel on these. And the reason there should be a catch funnel is for the fact that we have discharge possibly coming out from underneath these things. All right. This one's hard plumbed right into it. That's not good, right? You don't hard plumb these things. And a lot of times these have isolation valves before and after them too. So that here you can see there's isolation valves here. All right, this leads me to the next thing, which is considered a double check valve assembly. All right, so okay. All right, so this double check valve assembly is a testable assembly. I get that 100%. It's called an assembly, but double check valves are different than RPZs. And the biggest reason they are different is because they are for low hazard application or aesthetics. If you haven't caught on to that word yet, you need to know that word, what aesthetics means. Aesthetics means like the physical description of a thing, and physical can be color, taste, smell, that kind of stuff, right? And that's why I use, does it look bad, smell bad, or taste bad? So a double check valve assembly, as you can see, is 2 check valves, just like an RPZ, but it does not have a relief port here, okay? And another thing about it is there's no PSI lost across a double check valve. So a double check valve under normal flow, this is a bad, we got to get another picture of this, Bob, because how's it flowing when the check valves are shut? Just saying. It comes this way through, and anytime there's a disruption upstream due to back pressure or backsiphonage, the check valves will close, all right? But they are only for aesthetic issues, meaning you can't put these on anything that have anything chemically involved, okay? That is the biggest thing you got to understand about these. The main area you see double check valves are on fire suppression systems and untreated boilers. Those are the 2 main places you see them. And then in a beverage dispensing machine too, which I'll show you an example of those. Those are considered vented double check valves though, okay? So they are for back pressure. They are for back siphonage, but they are for low hazard only. Remember, aesthetics. looks bad, it smells bad, it tastes bad. It will not make anyone sick in any way, shape, or form. But it just aesthetically is displeasing, or it can have aesthetic issues in our water system, right? We all, well, maybe we don't all, but I'm sure a few times a year, a few of the cities that are on here probably get like red water complaints or something stinky when you're doing flushing, right? You know, a lot of times stuff being flushed out ain't necessarily bad. It's just, rust or whatever, but it still stinks. It don't taste good. Definitely don't look good. So these are called non-testable or vented double check valve assemblies. You have a 1022 here. This is an ASSE 1022. So if you're out conducting inspections, Bob will talk a little bit about tomorrow, but your beverage dispensing machines, you see the pop machine at the Speedway or the cappuccino machine at your Tim Hortons or whatever, you should be looking in the inside of those, looking for these stainless steel ASSE 1022s, okay? The other one here is a 1012. This is a vented double check valve assembly that we see on boiler systems, okay? Here's well, that's not picture one. I got one coming up. These are typically seen on boilers within homes and businesses that are not very large boilers, okay? You'll see these. And how these work is the water flows in one direction. If something occurs, they blow it out the bottom. That's why they're called vented double check valves. Is this an approved assembly? Well, let's see. There's isolation valves. There's two check valves in below. But what's missing from this that makes this not approved? There's no test ports. This is a MacGyver backflow preventer, and no, those are not allowed. Okay, I'm just giving heads up. On all the ones I've seen, I didn't see, threaded nipples in between here and unions on the end of them to connect them to pipes. This is not an approved assembly, all right? How about this? Is this adequate protection? Look, there's a vented double check valve, so behind the diaphragm valve there. Well, let's just bypass it. Who cares? Let's put a bypass in. Yeah, because that's a good idea. All right. No, this is not approved. You don't bypass your backflow preventer. All right. Pressure vacuum breakers. Pressure vacuum breakers are typically seen in a couple different locations, but these are also testable. You see the test ports here and here. These are considered testable. All right. These can have downstream valves on them. This is a big difference that you need to know between a pressure vacuum breaker and an atmospheric vacuum breaker. Pressure vacuum breakers work in this function. The water comes in, it compresses the first check valve, and then here there's a thing called a poppet, and it pushes that up. And when that pushes up, the second valve check in the top of this crown also closes, and it allows water to flow through normal things, okay? Back pressure vacuum breakers are not acceptable for back pressure situations, okay? They are only for back siphonage, okay? So that means there cannot be a pump downstream of this thing or a boiler downstream of this thing. That might create back pressure, because what occurs if there is back pressure or under high elevation, it's not to be high elevations either, because the water would come up, it will keep these open due to the pressure coming from this way and feed through. Back siphonage, there's a vacuum, and a vacuum allows it to go and it shuts. They can't overcome the springs, all right? It shuts them, but back siphonage only, and downstream valves are allowed. You need to know that, okay? The other thing about them is pressure vacuum breakers need to be 12 inches higher than the highest point of use. They can't be here and then right next to it be lower than 6 inches. Matter of fact, I was in Tim Hortons yesterday, and I reported it to my township because I noticed that a pressure vacuum breaker right next to a dishwasher, and it was maybe 3 inches higher. It's supposed to be minimum of 12 inches higher from the highest point of use, okay? So lawn irrigation systems and stuff, that's why you see these on the outside of houses, because this is the most commonly used area for those is lawn irrigation systems. And you see them on the outside of houses and businesses, and they are typically higher than the highest point of use by at least 12 inches, okay? So things to know about them. They are back siphonage only. They are used for low hazard and high hazard both, okay? They can be used for high hazard because if they're on lawn irrigation systems, as long as the pump is not downstream from it, but they have chemical additives to it, they are allowed because they're a high hazard application. You see these in marinas too and funeral homes, but lawn irrigation systems are the king of where you see these, just FYI, okay? Downstream valves are allowed, must be in the vertical position. So how about this? Does this one look good? That mushroom or the crown of that should always be pointed towards the sky. If you walk up and it's pointed straight at you, it is not installed properly because it installed horizontally. And horizontally, I've been asked why. Well, horizontally can affect how the check valves are affected. They could be opened by the pressure of gravity dragging that water down, creating kind of like a back pressure situation. All right. So they need to be installed vertically. Atmospheric vacuum breakers. Okay. So atmospheric vacuum breakers are non-testable. As you can see, this is our first quote unquote device. Okay. And the reason this is our device is, look, you don't see any test ports off this thing. These typically are found in two places. They're found in slop sinks or lab sinks, and then hose bibs out in on the outside of houses is typically where you see these. Not to see they can't be used in like commercial dishwashers or sinks. I've seen them in those areas too. They can be, but a lot of times they're not, and there's a reason for that. There are no downstream valves allowed because an atmospheric vacuum breaker has no mechanical springs in it where a pressure vacuum breaker does. How it works is exactly in its name. So the water comes up and there's a floating block in here. It's just a block. It pushes it up and it shuts it here, and the crown of it shuts it and it flows around. That floating block, when not being used, drops back down. And the reason it drops back down is because atmospheric pressure comes in from the crown and pushes it down. Atmospheric pressure is very light. Wherever you're sitting, or wherever you're at right now currently, you're being pressured by the atmosphere, the same as that block. Do you feel it all over your body? No, you don't. That thing is the same way. You can move freely, so there isn't a whole lot of pressure pushing that down. It's not mechanical, so it cannot have downstream valves. Because let's say there's a valve here and I shut it. What happens to this water? That water line stays charged and it leaves that block wide open. Does that make sense? A valve downstream leaves the line charged and leaves the device wide open for water to backflow. So no downstream valves. Just like pressure vacuum breaker, back siphonage only. Atmospheric vacuum breakers only need to be 6 inches higher than highest point of use. Atmospheric is 12, or pressure is 12. Atmospheric is 6. No, those aren't on the exams, okay? Is this okay? Can we have this like this? Is it okay to have this installation? It looks all right to me. Why not? I mean, come on. It's not. There's downstream valves here, okay? We can't use this. We could have a pressure vacuum breaker here, but not an atmospheric, okay? So where do we typically see atmospheric vacuum breakers? Well, they are for back siphonage only. They can be used in low hazard and high hazard applications. Oh boy, this is a typo. It's supposed to be 6 inches. Sorry, not 12. We need to make note of that, Bob. Downstream valves are not allowed. There's another thing that's interesting about these. They're not supposed to be used for more than 12 hours of continuous pressure or use. And the reason for that is that block that we were talking about can become lodged in the top of that crown. So it's not to be used for high hazard application. All right. So a couple things you see these on where they're really high hazard: janitor sinks, laboratory sinks. All right. We see those on the back of the sinks. Hose bibs outside, they can be considered high hazard because if you're using different types of chemical treatment that hook to your garden hose for stuff, guilty of it, been there, done that. I obviously removed it and stuff, but in toilets, all right, and urinals. Urinals, these things right here, this has an atmospheric vacuum breaker in it, believe it or not. So No more than 12 hours use, 6 inches, not 12, from the highest point of use, low, high hazard, back siphonage only, no downstream valve. All right. Yes, your toilet. It's I would be curious to how many people in this call or actually have done inspections. This is why I kind of wish sometimes this class was in person, but 140 people, we'd be in a really big classroom, just saying, or auditorium. But there's supposed to be a 1 inch gap from your fill, because this is how toilets fill, right? It flushes. This is your fill tube until it shuts here. There's supposed to be a 1 inch gap between the fill valve here and then the drain valve pipe here. I would be curious to know how many people actually open the back of a toilet and inspect this. My guess is probably not very many. I just had to rebuild a toilet at my vacation home. I made sure it was 1 inch straight up till I worked here. I never knew that. I didn't know it was 1 inch on the back of the toilet. So, other examples of atmospheric vacuum breakers. These are the other ones you see. Okay. This is outside, like an outside hose bib. This one is a frost one. What it is a lot of your older ones that were installed from like 98 back, they might be an atmospheric vacuum breaker, but they're not frost protected, meaning a lot of times if you go to inspect it and you turn it on, you're going to get a shower. I'm just giving you a heads up because they like to freeze up and bust. Been there, done that lots of times too. You can see here on sinks, this is a couple irrigation systems with them. As long as there's no valves downstream in the irrigation system and you only run it for 2-3 hours a day, they can be used on irrigation systems too. Obviously, here's examples of it. This one right here is what's called a hose vib vacuum breaker. So if you're inspecting really old homes, which like my parents' house, they don't have vacuum breakers built into theirs. You can get in cities typically hand these out. They're called hose bib vacuum breakers. And a lot of times they'll install them. And as you can see these little holes around the rim. What they do is they don't allow the water to come back through from a garden hose, even if there is a downstream valve, because it creates somewhat of an air gap here and it blows the water out here. Under normal flow, it just flows through. But once this valve's closed, it just kind of sloshes out here around it. A lot of times these have what's called a breakaway screw in them. So you'll screw it on, right? And then you'll tighten it. And with a breakaway screw, it means once it's tightened to such a point, the screw head just breaks off. And that's so that it's a permanent fixture. Though, from what I've been told, you can remove those somehow. I don't know how, but I guess if the homeowner's MacGyver, they can figure it out. I've been told by a few municipalities about that. So now we're getting into some technical stuff. All right. All that knowledge I just gave you or just talked about, I would say you should know that, just FYI. Okay. Everything must meet ASSE standards or CSA. What does CSA stand for? CSA, ask yourself, CSA, Canadian Standards Association. Okay. Michigan and 12 states belong to what's called the 12-state compact. And that 12-state compact includes Ontario. Okay. All the Great Lakes states, all the states that surround the Great Lakes. So they have to have similar stuff, and CSA standards devices and assemblies are approved to be used in Michigan. Okay. So they are required by plumbing code to meet ASSE or CSA standards, and they are required by Michigan too. All right. To be installed properly and meet the standards. What type of assembly is this? What is that? Not consistent across. Yeah, it's not. This is an RPZ. From what I've been told, this is not approved in Michigan, evidently, though. I got told that by some guy from HydroCorp. I don't know exactly why. That's a Bob question. But this is an RPZ. It's a metered RPZ. Typically, if someone's going to fill off a hydrant, my guess is 99% of the cities out there have a requirement that they have to use a city-approved RPZ fill device off a hydrant. You should not just be letting anyone connect to your water system to fill off a hydrant without either proper permits or or proper equipment or even supervision sometimes, okay? Because Corpus Christi, Texas in 2019 alone, Corpus Christi is a resort community right along the Gulf of Mexico there. Corpus Christi, Texas had at least 4 backflow events that were all based off hydrant filling, okay? The last one in the year that I had heard was like August of 2019 that year. I was looking for examples and quote, and I talked to a couple friends down that way. There was an entire subdivision of like 500 some people that were affected and got sick with different outbreak of fecal coliform or E. coli because there was a hydro seeding company in the neighborhood filling off the hydrant, and they had no permit, they had no RPZ, and had backfed into that entire subdivision stuff, chemicals and fecal stuff out of a hydro seeding truck. Hydro seeding stuff's not good. So if anyone's going to be filling off your hydrants, they should have an RPZ, all right? And it should be followed through the city's ordinance to be done properly. Yeah, I don't know either on that one, Bob. Okay, so here's a summary of the 5 different things we talked about and what they cover. As you can see, an RPZ, like I said, is typically the gold standard, and that's because it covers everything, all right? Okay, let's quickly talk about this and then we'll take our break, all right? So isolation and versus containment. So there's 2 different scenarios that we as cross-connection people should be looking for and be recommending to our industry customers, commercial customers, large buildings, okay, or even hospitals and stuff like that. So there's containment. So containment is exactly what it sounds like. So on the water line going into a building or into an industry or wherever, the water line coming in, you put a cross connection device on that or assembly on that, right? When you put that on there, and if anything ever occurs, any other type of backflow event, and it triggers that assembly or device, and it prevents the contamination of the public service, public water supply, right? That is considered contained because whatever happened is contained to that building, right? But that's not necessarily great because that means everything or everyone within that building is exposed to whatever the health hazard is that's in the water now, right? That's containment. Now there's isolation. In any given building, there's going to be different pockets of, machine shop, offices, locker rooms, whatever, just different parts of the building, right? Well, the different parts of the building all may use water differently. Isolation is where if say something occurs in a plating part of the building where they're doing plating. Well, if it is it's isolated to that area because say something occurs for a backflow event, but the backflow preventer is triggered and stops it and doesn't spread to the rest of the building because it stopped it in the plating part of it. A is exposed to less people, and B, it's isolated to only that particular area of the building. The rest of the building was okay. That's considered isolation, meaning different parts of the building are broke up by these and protected by these different backflow preventers. Okay. Or you may have to do a combination of both. Okay. I do not know of any city that doesn't require industrial or commercial customers to not at least have containment. Okay. Not saying that it doesn't exist, but me personally, I work with a few different cities, and I don't know of any city that doesn't require on any commercial or industrial line to have at least an RPZ on it. Okay. So isolation, it's preferred because it isolates it to a particular area of the building and it doesn't affect everyone. It can be cheaper. And we're just talking these 6, 8, 10-inch RPZs that might be, required. They can cost a lot of money. You could be talking 10 grand maybe put one of those things in. Whereas if you put a bunch of 1 or 2 inchers in, it might only cost you like 5 grand or something. All right. You should provide education to the people who work there, the people who own it, and to the managers, all right? Because maybe with education, you can convince them to put these in their business so that, you don't kill 100 people or make 100 people sick. You maybe make 5 people sick, all right? No backflow event is ever good, but to affect more people versus less, I mean, that's kind of self-explanatory. Containment. The facility is contained, public water is supplied. Frequent plumbing changes. Okay. So in large industrial buildings, sometimes it might just be so, or hospitals, it might just be so impossible because there's always something being replumbed, or you just can't trace the pipe. All right. You goes behind that wall and who knows where it goes, kind of thing. Confusing plumbing. It's hard to trace the pipe again. Access to it. Or you might be refused into the buildings. Like I said, you only have a very limited scope in how much businesses have to show you. All right. Facility employees will not be protected though during containment. Okay, so here's an example of containment. You have the service line, the meter, and you put an RPZ there and bang, it's contained to the building. If anything ever occurs, everybody's affected. Here's an example of isolation. So here you can see we got plating, we have treated boilers, lawn irrigation systems, and a non-treated boiler. Okay, so plating process is chemically involved. This will be an RPZ. Treated boiler, chemicals, RPZ. Lawn irrigation system, pressure vacuum breaker. Non-treated boiler, most of the time, because this is low hazard, will be a double check valve assembly, all right? RPZ, pressure vacuum breaker, RPZ, and a vented double check. Okay, vented double check or double check valve would be either one. And then as you can see, so if anything ever happens in the treated boiler area, well, it's contained there and the rest of everything else is okay. All right. Here's an isolation example. As you can see, the reason that this has 2 RPZs, okay, that's not acceptable. You can't put a cup as your funnel, just FYI. This is the water line coming, this is the meter. And then you see there's 2 RPZs here. The reason there's 2 is because the process behind here can never be without water. So it allows you to isolate one while you test the other and isolate the other as you test the other one so that there's always a flow of water. There's 2 RPZs. They didn't bypass anything. It's for isolation purposes so that there's always water here. All right, a cross connection control program. There's ordinances that you need to have because that is required by the Safe Drinking Water Act. That will specify inspection frequencies and testing frequencies. There's high hazard and low hazards. You have your different list of accounts, commercial, industrial, governmental, institution. And then the biggest one, unfortunately, is residential. That is the one that most cities are lacking on, is the residential list of accounts, because there's only so much you can do, right? And only so much you can see. Residential is huge, and it's becoming more and more of a threat to the water system than ever before. There's inspections. Inspections depend upon frequency, as on if it's high hazard, low hazard, scheduling appointments, perform and document, and then follow up. All right. And what the follow up is to make sure that if something's been tested and it's bad, it's been repaired. And then there's device testing, reminder letters, record keeping. You have to keep these for so long. And then there's the test report review. Okay. Record keeping is key on this because this can and will be checked during sanitary surveys by your district engineers. Bob can give you more information on that. All right, so stuff that has changed recently, and by recent, it's been a while, but in order, specific references to residential accounts, as far as like lawn irrigation systems with testing and inspections. The reduction of testing was to 5 years if it's irrigation with no treatment. It isn't 3 like most low hazards, it's every 5. And then in order to test these, you had to be ASCE 5110 certified to do so. That went into effect January 1st of 2018. Before then, it was just anyone who was a licensed plumber could test them. Now, anyone, as long as they're certified, can do that. Ongoing debates is testing frequency, implementing the cross connection program in a residential setting. This is very hard because cities are, where am I going to get the manpower? Get it 100%. So That's why I'm glad I'm not an engineer and have to be involved in that discussions. All right. So do I have any questions about this before we take our first break? I guess it's first and only break, to be honest. So no questions. All right. So Matt, let's go ahead and do our 6-minute break, and then we'll come back and finish up the second presentation. All right.
All right, sounds good. I'm gonna go ahead and put a timer out here and we'll go from there.
Hi, everybody. Welcome back. We should be getting back from break. Here it's been our 6 minutes, and then we got another little presentation here. And if this one won't take me here, it's pretty short. So with that being said, Bob will most likely pop on at the end here and do a little bit of presentation about like the annual report, or I don't remember exactly what he said, annual report exercise or something. Or we might answer some questions. So everyone should be back from break at this point. And Matt, will you go ahead and run the second poll question for us if you can?
Okay, so that poll is up and running, and we just want to know, are you taking this course to prepare for a certification exam? So remember, Zoom does need to be your active window. And you should see the poll screen pop right up on there. Looks like over 100 of you have already done it. So we'll let this poll run, try to get over 90% participation on the poll. And just a reminder, if you need continuing education credits, then you do need to answer the polls. If you are having an issue with the poll, please let us know that via the Q&A dialogue question box. If you have a question you want to ask live, we can unmute your mic. You can indicate that by raising your hand. And that would be for questions that pertain to the content that Scott has covered. So it looks like maybe some of you may be seeing a different question than what I'm seeing, which is kind of interesting. In that case, just make sure you answer the question or answer a question, select a question or select an answer. These are to gauge your participation in this webinar. If this is your first time doing a virtual session with Eagle and using Zoom, you just want to make sure after this session that you do update your Zoom client so you do have the latest software interacting with our virtual course. All right. Looks like 94% of you have answered the poll. I'm going to go ahead and end the poll and share the results. So Scott, you can see almost half of the attendees are using this information to prepare for a certification exam.
All right. Well, yeah, I've just the reason I was curious about that question is because the stuff we just covered is definitely the stuff you should know for a certification exam. Just FYI, okay? I'm just telling you, it's not that it's good knowledge too, just to know, because a lot of people are unfamiliar with what the cross connection assemblies and devices are. They're unsure where they should be looking for them. They're unsure how they should be installed, or so on and so forth. I see it time and time again. I teach lots of people. I mean, it's like, look, I got 140 on the session today. I know Bob's my co-instructor, but I teach hundreds. I guess it's probably fair to say I've taught thousands of people almost every year, right, Matt? And when we talk about or get on this subject, it's amazing to me how many people don't even know what a cross connection is. I was just in a municipal setting the other day, and this guy's been a contractor for like 10 years installing water main. And he's now working for municipality. And I mentioned cross connections. He goes, "What's a cross connection?" And this is a guy who's installed probably miles and miles and miles of water main in his 10 years of doing it and doesn't know what a cross connection is. So it's very, very common that people don't know. And then the other thing is I saw a response by Emily up in the city of Saginaw. She works in a water plant. So even, I mean, she knows what cross connections is. This isn't her first rodeo with them or discussion about them, but cross connections exist in water plants too, right? it can be a possible issue there. Same with wastewater treatment plants, obviously. All right, so let's go ahead and get started with the commonly asked questions power slideshow, and then we'll get down here through that stuff. So, all right, let's go with this. Okay. So this is part of the commonly asked cross connection questions that people get. I get, even though I'm not an engineer, Bob, you would be surprised how many calls I get about this for the fact that I've been teaching it for the last 5 years now. So when should backflow preventers be tested? All right. So testable devices or assembly, we need to change it. It should be testable. What's up? Who's talking? Were you going to say something, Matt, or was it just you forgot to mute yourself?
No, I'm going to mute my mic.
Okay. All right. So the testable assemblies must be tested in different things. All right. First off, they need to be tested at installation after any repair has been done. Well, why would we do that? Well, first off, at installation, make sure it's working properly. After repair, for the same reason, make sure it works properly. And then within your approved cross connection ordinance that you have or plan, every city has an approved plan. Some of them and most of them are most likely from the 70s. So it's been a while since they've even been updated. But within that thing, it spells out how often you need to test your devices. Well, now, according to Michigan law, because we updated it, as you saw in like 2018, things went active. High hazard devices always and should be tested annually. Okay. They need to be tested annually. High hazard assemblies or accounts should be tested annually. Now, low hazards are every 3 years. So like your backflow preventers that show up on fire suppression systems or low treated boilers, like a double check valve assembly, is every 3 years. And then lawn irrigation systems, as long as there is no chemical additive to it, is every 5 years. Okay. I sat through the rulemaking process of all this when the new rules were being written and added to in like 2014. And it was crazy. No one really gave a crap about any of the other stuff. The only thing every city cared about was the lawn irrigation system. Like, because we initially had it as 3 years, but like, man, there must have been 10 cities at least there complaining about it. And we decided through the rulemaking process and stakeholder groups that 5 years was acceptable, and everyone agreed to that. So that was the only thing that really changed from what we already said about 1 year, 3 years, and then 5 was added for irrigation systems. Okay. So who can test a backflow preventer? So I've already said it in the last one. You need to be ASSE 5110. All right. You can see here 5110 on that slideshow. If you go to the ASCC's international website, which right there's the address, iapmo.org, you can find testers, repairers, and many more. Okay. So to this day, still, it is not, as Bob indicated, it's being discussed. But as of right now, the only people who can repair industrial and commercial have to be a licensed plumber. Okay. Now, if it's a residential device or assembly, it can be installed by the resident. It can be repaired by the resident. All right. In order to be tested properly, though, it would still have to be ASSE 5110. The resident can do it, assuming they get the proper permits to do so. Okay. So it's not a given, and I wouldn't recommend it. Okay. There are not very many proper people who are mechanically inclined to do so. Okay. So testers, you can find them on the website. Repair people still have to be licensed plumbers, as far as I know as of today. Like Bob said, there's discussion about it. So in the future, because there is a certification to become a repairer through ASSE, but the state of Michigan does not recognize that at this moment. Okay. Tester must be ASSE 5110 certified, must be. Okay. This is a state law. It says that now. So who can install them? Okay. So to install, repair a device, a plumbing permit must be obtained by local or state permitting authority. This includes residential, but this is where it's a little bit different. For commercial industrial buildings, a licensed plumber must do it to install it or to repair it. Okay. It cannot be done by GM just because they feel like it. They might have a plumber on staff that's licensed, maybe so, but they don't. It can't be done just by John Doe. Family dwellings, 1 to 2 family dwellings, so like man, what do they call those? I lived in one too. I can't remember what they're called. But they got, a living residence on each side of the house. Whatever. I can't think of the name, but off the top of my head, I lived in one too. Anyway, they can be done by the homeowner. The homeowner can install it and repair it, but they have to have a valid plumbing permit. And of course, someone's probably telling me what it's called. A duplex. Yeah, there you go. Thanks. I lived in one. I lived in one for 3 years. I can't remember what it was called. Sorry. But a homeowner can install them and repair them themselves if they have a valid plumbing permit. Again, to be tested, though, still got to be ASSC 5110. Because a homeowner, I guarantee, I'm very mechanically inclined. I could install one. I probably could repair one of those. But I don't know how to test it. I don't know how to do that. Very mechanically inclined. I mean, I just put wheel bearings and half axles and struts in my truck. So I'm very mechanically inclined. What test forms are allowed? Okay, so each water utility within their ordinance needs to decide what test forms they're going to have filled out by ASSC testers. There are generic ones, right? Some will just accept any generic form that is given to them by that the tester chooses to use. Some will only accept specific forms. That is up to the utility to decide. Whatever one you do, that's okay. You should pay very close attention to keeping those records, maintaining those records, and reviewing those records, okay? Reviewing those records gives you an indication if the tester is doing it properly, it's being done at the frequency it should be, and that it was done correctly, okay? Because let's face it, right? Not everyone's going to be great at doing the testing. They might just, what's the right terminology with being politically correct? They might shortchange you on the form. They might not fill it all out and claim they did the inspection. Another thing that sometimes you should be looking at is after these things have been tested, there's supposed to be a tested date tag attached to the assembly. You should maybe spot check to make sure that the form matches the tag. Make sure the tag is even there on the assembly itself, because that tag gives you or gives someone, the idea or the trail, quote unquote, of the paperwork, meaning I could look at the tag, see it gives me code, I could go to the city, and you should have that paperwork. That's where you need to maintain that stuff. All right. All right, next page. Am I required to conduct inspections on residential accounts? Yes, it is part of your cross connection control program. It doesn't matter. You need to do it, whether if it's in a commercial building or a home. But I told you, with the home, to build confidence with or build rapport with your customers, you shouldn't be too intrusive. You shouldn't be walking through their home, opening every single closet door or something like that. Typically, a mechanical room, which is usually in the basement of a house, or a mechanical room somewhere upstairs, and the outside part of the house is the only places typically for residential you need to inspect, okay? But the highest priority should be placed on your high hazard accounts, right? Which 9 times out of 10 are your industrial customers or business like restaurants and car washes are typically your most common high hazards, right? Any industrial type complex like GM or any of them, they're going to have plating, they're going to have machines that run it, and there's lubricant mixing and so on and so forth, water jets and making motor blocks and that kind of stuff. So industrial and commercials are 9 times out of 10 your high hazard accounts. It's not to say that residential do not fall under that purview, because I told you, I know someone personally who sprays plant hormones through their lawn irrigation system That's a high hazard account, man. It's a chemical additive. So residential can be that way, but 9 times out of 10, it's typically commercial industrial accounts. Homes with lawn sprinkler systems. I just talked about that, right? Homes with private wells. Believe it or not, this still exists. And those need to be inspected probably to make sure that there is no connection between the public and that well. Some people only have a private well to use for their lawn irrigation system because they didn't want to get rid of it. You need to make sure and ensure that there is no connection between those two. Homes with pools and whirlpools, right? Well, what's in that? Lots of chlorine. There's lots of chlorine in those pools. Typically, a pool runs anywhere from like 1.5 to 3 parts per million of chlorine. Ingesting that high of chlorine levels can make people sick, right? Have you ever swam in a pool or your kids swam in a pool, they swallow too much pool water and puke later? Yeah, been there, done that, right? Homes with solar panels. Okay, we had a little bit of a discussion about this earlier. There's only currently how this works. Older solar panels used to use water, newer ones don't. Or some people in summer months here use solar exchange systems, which have water in them. They heat up and they use that water in a heat exchanger. So it like runs through these black solar type panel things that heat exchanges out of them, and they use it for like their heating. They use it for their hot water sometimes, like within the house itself, because it's something that requires just a pump basically to move the water around. But there is a heat exchanger in there, right? Current newer solar panels don't necessarily use water, but older ones do, and exchanging systems do too. All right. So am I required to inspect the whole home? No, you're not. Reasonable expectation of this is what I was telling you, right? You should try to be upfront with your resident. You shouldn't be going, just be straight up with them. Either provide them with educational materials to have them look around their house so that that maybe at a later date you can schedule an appointment to come look to see what they got. Because in that regard, they may look around their house and say, oh, okay, it's in that mechanical room over there, or it's downstairs in the corner, and I got one out in front of my house. So give them educational materials with understanding what cross connections are. Give them common pictures of them so that they can help identify where they are, and then maybe schedule a follow-up appointment with them so that you can come back and they can show you where the stuff is. Then you don't got to walk all over the house, and it saves you a ton of time. It saves you a ton of time, right? So typically outside of the house, mechanical rooms or a basement where the water line comes in. That's where most of them are in residential are. Though I will say this has drastically changed in the last, whenever the legalization of marijuana occurred. I don't know, 2 years ago, whatever it was, 3 years, I don't know. But whenever that occurred, this has changed things a little bit too. So that's why I recommend giving out pamphlets with pictures of these things, so on and so forth, so that they can kind of do the inspection for you and then schedule a follow-up with that. All right. Is containment or isolation preferred method for eliminating cross connections? Isolation is always preferred. And the reason for that is it protects most of the occupants within a building, right? We talked about this. Containment is allowed. And I will tell you, if you don't have containment in your ordinance, you should add it, especially for industrial and commercial customers. Anyone who's an industrial or commercial customer should almost always have containment on their lines, always. I know most cities that I deal with, it is on there. They have at least a minimum of containment within their ordinance that is required, okay? I would very much, if you don't have that in that ordinance, I highly recommend you put it in, and you should update that, okay? What is classified as a high hazard? Typically, high hazard is, it can immediately, I said this in the last one, it can immediately affect the health of people. Like if it's ingested within pretty much a 72-hour time frame, something is going to happen to that person. They're going to get ill, they're going to get sick, they may even die. The latter don't happen very often, and we definitely don't want the latter to happen, but it's always a possibility. You never know. Chemicals affect everyone differently, right? Typically, if you hear the word chemically in it or chemicals are involved, it's an automatic high hazard, okay? Chemically treated boilers, car washes, wastewater treatment plants, and any facilities where chemicals are used in contact or could come in contact with the water system. What is classified as low hazard? Low hazard, they don't have immediate health impact. They have aesthetic issues. I've said it over and over again, right? Aesthetics. It looks bad. It smells bad. It tastes bad, okay? Those are typical low hazard applications, which are non-treated boilers, strip malls, office buildings, most homes, my home is a low hazard. I don't even need a thing. I don't have a irrigation system here. I have, 2 hose bib or atmospheric vacuum breakers that I put hose bib vacuum breakers on anyway. And that's it. I got a air force furnace and gas water heater. That's it. I got nothing else in my house. So is my house is not considered a high hazard by any means. Most houses are not. All right. And then other buildings with small internal plumbing. All right. Typically, if a fire suppression system does not have chemical additives, it is considered also a low hazard. Okay. But if a building has pools and stuff in it, and if they're not on their own system and there's intertwined piping, they're considered a high hazard. All right. Is the water utility required to inspect and test backflow preventers in their own buildings? Absolutely. First off, you should be setting the example for your community. Every municipal building, lift stations, pump houses, you name it, your water plant, your wastewater plant, office buildings, town hall, whatever, anything that is city owned or municipal owned, you should be the first and foremost person within your community to be on the up and up with your cross connections, right? It should be inspected at frequency, should be tested at frequency, and act as a role model for your community. And tell your story about it. Tell your story about how you did this and how you did that, because it helps residents understand what you're doing and why it's important, okay? I'm sorry, but isolation is an absolute must too. I mean, if you're going to try to encourage it within your other industry buildings, you should probably be doing it yourself, right? Have all devices tapped. I just said this. You need to follow your stuff, be the example for your community. If you're not, if you're not doing it, why should the residents do it? That's exactly what you're going to hear, correct? And here it goes: water, wastewater plants, booster station, everywhere you can think, right? Cemeteries and parks. I left that part out. Yeah, cemeteries and parks. If they're there, you should do them. How often do I need to update it? All right. So the problem that we have with this is most people haven't updated these things since the 70s. All right. These should be updated. All right. I'm not going to tell you there's a set schedule, but a lot of times within that cross connection control program, in order to get it approved back when, there had to been a thing that says it needs to be updated every 5 years or 10 years, something like that. And then it was approved by the state. All right. So it should be updated when you think and by the schedule within the ordinance itself. Okay. You should have a plan to revisit your ordinance. I'm going to tell you, I think our district engineers say every 3 to 5 years as a recommendation. That's my guess. Correct, Bob? Am I wrong on that? You can speak up and unmute yourself if you want.
Yeah, in general, it's usually we're looking more so just at the contents and are you able to effectively administer your cross connection control program. If not, you need to look at, are there missing parts? Are there things that are outdated? So 3 to 5 is maybe a rule of thumb, but even that's not going to be a hard and fast rule.
Right. If you can't find your local program, you better definitely update it. Let's get a new one. There are sample ordinances and so on and so forth in the cross connection. I don't want to call it the rules manual, but I do believe that's the name that's still on it. Or I think I changed. I don't know. Whatever. The cross connection manual that's on our website, there is example ordinances and stuff in the back of that to give you at least a start. When do I install an RPZ instead of a pressure vacuum breaker on an irrigation system? Well, if back pressure because there's a pump could occur, that's when you do it. All right. And if the downstream piping, if it's not 12 inches, okay, so there's a couple, one of them. So if there's a pump, it's got to be an RPZ. And if there's not the 12-inch gap, it needs to be an RPZ. That's when you would do that, okay? 6 or 12 inches. Pressure vacuum breakers must be at least 12 inches from the highest point. Continuous pressure is allowed. Another thing to note about pressure vacuum breakers, you can have a downstream valve too, right? But if there's a pump downstream, you can't do it. The pump has to be upstream from it, not downstream from it, okay? In atmospheric vacuum breakers, 6 inches above the highest point and no valves, and not allowed to be under 12 hours of continuous pressure or use. As Bob had indicated, there's been debate back and forth. There is no necessarily set industry standard for what these say. Because if you install a Watt versus a, I can't think of another brand. Watts is the only one that comes to mind. I know there's other brands out there, but they all have, is there like another one like Zinco or something like that with a Z? They all will say different things. The one manufacturer say 12 inches, the other says 6 inches. So we're trying to say pressure vacuum breakers is at least 12, atmospheric 6, but this is an ongoing debate. This might also become 12 at some point for those, okay? It isn't on the exam though, because of the fact that there is no steadfast rule on it, or so on and so forth. There isn't exam questions, okay? So don't necessarily fret about that, but at least make sure in your system that it's at least 12 for this one and 6 for that one when you're doing inspections, okay? My sink has an overflow. Sinks and bathtubs have overflows. If you've ever wondered what that silver plate is at the head of your bathtub, that silver plate is an overflow drain. Okay. It doesn't count as an air gap. And the reason it doesn't count as an air gap is because that involves a lot of, what's the right word? It involves a lot of heavy calculations to determine whether that thing could keep up with the inflow of water into the sink or tub. And not a typical resident's not going to do that. I'm sorry. So the air gap is when the sink faucet is at least 2 times its discharge diameter above the flood rim of the sink. Does that make sense? And the flood rim is just how high is the sink? That's the flood rim of it, okay? It's too much to try to calculate. Like I said, that's a lot to do. To be honest with you, and I'm the math guy in quotes at the state, I would probably struggle to figure that out, at least initially. So that's, I mean, can I install meters on check valves and be done? No, you can't do that. You can't just put a check valve because a check valve A isn't a backflow preventer, and B, we don't know that it would be adequate enough to prevent a backflow if anything were to occur. So a check valve is no, can't do it. And most likely it's probably not ASSE certified and it could mess up with the plumbing. Okay, so no, it can't be. It needs to be a backflow preventer. Do I need to review my backflow test reports? Absolutely you do, okay? And the reason for that is a couple reasons. You want to make sure it's being done properly. You want to make sure it's being adequately done, that the tester is not shortchanging you. You're going to find bad testers and you're going to find good testers. I hate to tell you that because we would just hope that everything's lollipops and rainbows and the people are fantastic. Everyone's great. But that's not the reality of the world we live in, right? Some people are going to be bad. Some are going to be good, even if they are all ASSE certified. Okay. I'm just telling you, with reviewing them, you will know who's good. You will know who's bad. And another thing you should do upon reviewing the records and maintaining them, you should go out and check that paperwork against the tag that is put on by that tester. If they're not putting a tag on, then you shouldn't use that tester anymore. Just take a word of advice. All right. Why is testing required? Mechanical devices fail. RPCs, double check valve assemblies, and pressure vacuum breakers all have mechanical pieces to them. Let me ask you this. Does your car break down? Yeah, it does. You think the mechanical device will break down? Yeah, sure will eventually. Everything fails over time. There's not anything that I can name that works perfectly forever, besides like, the river flowing down the thing. It ensures the functionality to make sure that things are working properly. Tested is part of protecting your water system. All right. Okay, so I am done with my commonly asked cross connection questions, and I hope that you maybe learned a little bit from that, and that it was useful. And I think now we're going to have Bob go ahead and talk about the annual whatever, something another. So
Yeah,
Bob,
yeah, we can start first just to see if anyone has any questions out there. I want to make sure those get answered
Right.
from either of these two presentations, because this is stuff you will potentially see on your certification exams, and we want to make sure that you're comfortable with this. If we do end up with some extra time, there was an extra handout about annual reporting that I can very briefly go over while we still have some time. But first, again, we'd like to open the floor if there are any questions.
it can be about anything. So we're here to answer any questions we can. And other than telling you exactly what's on the exam, I can answer questions about that too, because I am the guy who does that. Certification exams is part of my job. Nothing? Out of 141 people, you guys don't have, or 140, there's no questions at all about anything you've seen. Either I'm that amazing or no one wants to talk.
I'll give it about one more minute or so, just in case people are busy typing. Again, as Matt had mentioned earlier, if you want to use the raise hand function, we might be able to unmute you to ask your question, if that would be easier.
Okay, I am showing a raised hand here. Noah, we're going to unmute on our end, so you should be able to unmute your mic on your end and ask your question live.
Yeah, I was wondering if there are any quick ways to differentiate between treated and untreated sprinkler systems at a residential location.
Typically, no, that can be done one in a couple different ways. So if you gain, because irrigation systems operate a little bit funky. Typically, how we see installation into them is you see the water line come in and then it splits. And typically, the pump or any chemical injection is going to be very near where it splits to go to the feed the lawn irrigation system. And I'm assuming you're probably not a water treatment plant operator. Is that correct? In assuming. And if you're not, you're typically distribution. You're either going to see a couple. Let me pull up this real quick. You're going to see like chemical feed pumps sometimes, or what you will see is a little chemical injector for water irrigation system. I can picture what I'm talking about. They're either doing by a chemical feed pump, or you see these little inlets like this. And let me show you what they look like. Share screen. Okay, hold on. They look like this. So you'll see a little inlet like this that has a flared nozzle on it for a chemical feed, and then it'll be hooked in to like another device. And the device can be a different kind of pumps. There's called peristaltic pumps and diaphragm pumps. But typically the thing you're going to look for is you're going to see a copper connection with a spline out of it and a little hose. Does that make sense? And you see how it's spliced into like a water pipe here? That's the main two ways you can see it. Or you'll see this spine, and then there will be just a little like clear type bottle thing with a black, like it just looks like a bottle that holds some sort of chemical to it. And that way can be fed through what's called the Venturi effect, where it just kind of sucks it down at a slow rate. So this type of chemical injection, you're going to see typically a large irrigation system for a really big lawn. And then the gravity or venturi feed ones, you're going to see in small apparatuses hooked to this spike or spline, okay? Yeah. How long do cross-connection report records need to be kept for? Will there be an issue for us to get CUCs in one computer? Followed with me with an email on that, Matt. As far as how long do records need to be kept for cross connections reports? Bob, do you remember that?
So I was just double checking our record retention
I think it's
document.
5 years, isn't it?
It's not one of our ones that are explicitly stated. I would say if you have any accounts where you've had something that needed to be fixed, whether either one of the backflow preventers was broken, you had an unprotected line, we do have a minimum of at least 3 years for any corrective actions. What I would say in most cases, I would put a lot of these under water system information. We generally will recommend those as either indefinite or until superseded. And I think that superseded is probably what you're going to be interested in as far as water systems go, because when you're getting this huge volume of paperwork, you're going to want to be able to go back at least until the last time a property was visited in terms of what did we find at that inspection, or the last time this was tested, how did it perform? Beyond that, if you're able to keep it organized and find files when you need them, you can keep them for as long as you would like. But I would say at least have one visit prior for that address or for that customer.
So Anthony, I know it's not cross connection related, but if you haven't heard yet, the word on the street is that there's maybe possibly a practice test coming for every license type. That is a true statement. I have, from my understanding, my boss made it publicly known that we are actively working on that. And I will tell you, we are in the final phases of the practice tests for limited treatment, distribution, and complete treatment. Answer keys will be provided along with those. We're in the final stages of review before those get published. We're hoping to have them out before the May exam. I'm not going to give you a deadline between now and then. Just sometime before now and May 3rd is when we plan to have those out, okay? Just so you're aware, that is coming. I've worked on the complete treatment and limited treatment ones and have completed my part of it. We're doing the final review. We're in the final stages of it, so we're almost there. I'll type my email in the chat, I think. Or can you only do that, Matt? Oh, there you go. Anything else before we maybe turn it over to Bob and let him?
Yeah, I don't see anything else in the Q&A. Are there any other raised hands out there, Matt?
No, there are not.
All right, I will go ahead and plan on briefly sharing my screen then. Oh, there's one more about the tests. I'm going to guess the practice exams for you, Scott. in the Q&A.
Absolutely, it will be, Christopher. That's part of what we're doing with the last part of it. They have to go through ADA accessibility before we just put them out there. It will be on our website. Everyone that's there, it will be out there for everyone's enjoyment. We're not going to hide it. It'll be out there on the OpCert website. Just, it's not ready yet. Like I said, we got to go through a million hoops before we can just put something on the website, especially something of that magnitude. So it's coming. It'll be on the website, I promise. I'm the website administrator for OpCert, meaning the minute it's done, the minute it'll be out there. I promise every single one of you that as soon as I can put it out there, I will. Okay.
Yeah, and to that end, whether it's for exam materials, you're looking for people's contact information, you will be able to find most of that on our drinking water community water supply website. For Scott and his coworkers, we have an operator training and certification unit. They have their own little page. We also have district maps where you can get contact information for myself, as well as my other counterparts across the state for whoever your district staff is. So whether you think of more questions before we end our session today or after we have our session tomorrow, you can always visit there to try to get some more information or figure out maybe who you can speak to. So for our last few minutes here, we did have this listed as going till 11:15. I wanted to take an opportunity to go over, we had this one other attachment. It was not originally included on the agenda because we did not know if we would have time to get to this. We came up with what is hopefully going to be a useful example for anyone who goes through the process of finishing this annual cross-connection report. This is one of the annual reports that we require water systems to provide to us. It's right up there with, we have for people who don't complete MORs, they have to turn in a pumpage report. You have to do a consumer confidence report. This is another one of those documents. So for some of you, you might be very aware of these are. Some of you, maybe you just hadn't had the, whether you consider it opportunity or misfortune to have to do one of these. And then some of you may not have to do, deal with this directly. You may have a supervisor or someone else who will take care of this. But for this document, so basically, as I was saying, just this is due every, I believe it's the end of March, that this must be submitted to our division. And we do look at these. We try to find time occasionally, but we do review them for information because this is basically your progress report on how is your cross-connection control program doing. So just the very first thing is, where do you find these? We do have templates of the forms available. This is part of our previously mentioned community water supply website. It might have gotten a little bit of a facelift since the screenshot was taken, but we do have a link that will say reporting forms. Within that, there will be a subheader that says cross-connection reports. When it comes to these forms, there are actually two versions that you can make use of, and not everyone is aware that there is this second version. When you go to pick one, we will have both a Word document and PDF form available. Whichever is going to be easier for you to use and edit, please make use of it. When it comes to the two types of forms there are, we have our standard form, which is what most people are going to be familiar with. Typically, municipalities are going to use this, as well as it might be other systems. They're a little bit more complex, either different customer types, just it's not easy to just drop everyone into one bucket. We're going to treat all of you the same. For some of these smaller and simpler systems, we do have what we refer to as a residential water system form, which is basically, you don't need to figure out who's doing what with the water. Everyone, they're the same customer type. We don't need to be separating people out. So for the standard form, this is what it's going to look like. And again, this is probably what most of you have seen. It's going to have space where you identify who is completing this form, basically who is this information coming from, and then it just spells out who, what kind of users might we be seeing, and we're breaking it down between high hazard, low hazard, what was the amount of work that was going to be expected for that previous year in terms of how many accounts did we do inspections at, how many assemblies did we have testing. All of that is going to get reported to us, as well as then if you found anything, was it a problem? Will it need to be fixed? And again, that's blowing that up a little bit just so you can see it a little bit better. And then the backside, it will have an instruction sheet for what are we looking for. The residential only form looks a little bit different. And basically it's just, again, you're reporting, did you have any, what inspections did you do? But where it gets simpler is it's just saying, did you have any testable assemblies, or what kind of backflow preventers do you have? It's got this whole key and you're just checking out, yes, we have that, or no, we don't have that. And then just, if any of them needed testing, did you get to them? And again, it has this second instruction sheet. So what this whole slide or this whole PowerPoint is, this series is going to just go through the steps of how do you go about completing one of these? And specifically, the example we're going with is how do you complete one of these standard reports? The very first step is going to be, we'll get all your information. This is going to be whatever records, if you contracted it out, what did they leave with you? Are you completing your own paperwork? Maybe you're using software to track this stuff for you. There's a whole bunch of different ways out there, and I'm really not going to say that one is better than another, as long as you are able to find all of your information. If you can do that, it's a workable system. And then I do know I'm going very quickly through all this, but it's just because we have limited time. This is going to be a handout available to you, and you can go at your own pace looking at some of this. These are just examples of maybe what some of the inspection forms look like. Again, there's going to be as many of these, probably close to as many water systems as we deal with. There's no template necessarily. There's not a right or wrong way. It's just, are you getting the information that you need when looking for cross connections? And then can you go back and find that information? So then it just comes to starting to fill out the form. So as I'd said, one of the things that makes the residential one different is this section about maybe what cross connection risks do we face? How are those being addressed? Again, we've got highlighted here, what do those mean? And then when it comes to actually going through the form, what you'll see as we go through these slides, it's broken out step by step. Our first step here, we're filling out basic information. Again, this is telling us what water system or who is completing this, where are we getting the information from? And then there's a line here where you should have, where was your most recent cross connection program update? So on this particular example, it was from 2011. The next step is going to be just, again, what accounts are we dealing with? And for these first lines, it is specifically going to be what's your total number of accounts that you're working with. This is still just generic information, not stuff specific to that year. The next line then is where we're actually breaking down these numbers. How many are high hazard? How often does your program say you're supposed to conduct inspections? Then we have our low hazard, and again, how often are we supposed to have inspections done at these low hazard customers? These exact frequencies, again, that is coming from your cross connection program. You have guidance or maybe minimums that are going to be put out there by the cross connection rules manual, but these exact frequencies are self-determined. Particularly when you're coming to low hazards, you can have a very wide range of how often you're getting to these places. And it is basically going to come down to just, through manpower, how much time you want to put into this, how often are you willing to commit to actually get to these places. So in this case, when I'm looking at this form, if this is how it's reported, I'm expecting there to be, the goal is anyways, to have 50 re-inspections done in a year, because they're supposed to be every 12 months. And then on average, 125 low hazard, because we're taking this 250 and splitting it over every 2 years. Then for our next lines, it's reporting what was actually completed for that year. So again, we're seeing the 50 and 125 I mentioned. And then there's also this line that says initial inspections. And we've got a little bit of an explanation here. An initial inspection, what we're asking for in this line D, and then your re-inspections that are in line E are different. An initial inspection, that's going to either be new construction. Maybe you have a customer that totally changed up their plumbing arrangement. Just basically, when you get there, the plumbing is not something you've seen before. So it is the first time you're getting to look at it, and we're making sure, was it all properly built? If we had to have backflow preventers, were they installed correctly? It's that first initial time you're looking at it. For the remainder of the accounts, these are things that we've looked at before, and you're going back to make sure that nothing has changed. So in this case, we had 17 that were looked at for that first time, 47 high hazard re-inspections that were completed, 100 low hazard. So these are slightly below what our targets were, but they are close. As well as then we had these 17 initial. So on the whole year, we had 147 re-inspections plus the 17 initial. That's going to be 164, which is pretty close to our 175. When we're doing our reviews, one of the things I want to make sure people know about, we're not expecting you to bat 100 to get every single one of these every single year. Complications come up. You have emergencies that come up at a water system. You have just, maybe a project every year. You had to deal more so with infrastructure work, things like that. Or a great example was 2020, 2021. We had pandemic restrictions, and we had a lot of municipalities, water systems. They were greatly reducing these inspections going out to people. They didn't want to put their customers at risk. There were residents that weren't comfortable with people being there. There's a lot of things that can affect what that number looks like. We're going to look at these as a set of over a stretch of time. How has the system performed? If you've had these up and downs, but in general, you're pretty much right at expectations, we're going to consider that an acceptable working program. If we're consistently missing the mark, that's where we're going to express concern. That's where you might start seeing some citations or start getting some of this correspondence from our division. So in this case, then for F, G, and H is basically we're looking at where did we find problems? And then what has been done about those? So in this case, of the accounts that we did inspections or re-inspections for, we said there were 23 we found a problem at. And this could be either something was removed, something was broken, or something that was supposed to be there was never put in. Any of those, just for whatever reason, we have a cross-connection problem, it's going to require corrective action. Well, then the next line is saying, how many of those did we perform a corrective action at? And for some of these, it's going to be as simple as, say, if you find one of those hose bibs, doesn't have anything on it. And I know people that will just drive around in their trucks. They'll have some of those hose bib vacuum breakers. They're there at the visit. They might just screw one of those on. All right, so right there, you've already identified something, and now you fixed it. That should count both on this line and this line. And then the difference between these being 3 means that we have 3 accounts left out of compliance. So that gives us the 297 number, which all that is this 300 minus 3. All right, I see there's a couple questions coming in. So Josh, as far as your question with that, we do get these templates updated. So these ones are going to be, if you've noticed, this one with this example is from almost a decade ago, or actually is just about at a decade ago. We do update these as far as getting the year and everything updated. The general format in terms of what you're seeing, what information we're asking, that has not changed. So this is going to be the kind of template form that you're seeing when you go to our website. And then for these last couple lines, well, this slide just has the examples of what are the kind of things you might encounter. And again, we want those reported. We want to know that you're finding things. And that's one, if we have 0 after year, that kind of raises our suspicions, because now it's going from, we see it once or twice, great, things are working awesome, it's where we want them to be, to now we're going to start questioning, well, are we looking in the right places, or do we know what we're looking for? Because just whenever you've got these systems, there's a lot of customers, there's a lot of people that you're delivering water to, and a lot of different ways they're using it. Stuff is going to change and happen. And it's not even that anyone is doing anything, I mean, purposefully on wrong, or that they're trying to be a problem for you. There's a lot of people, they just don't know. Just again, things happen. So that's one of the lines that we're going to pay attention to. And like I said, even if it's as simple as that hose bib example, give yourself credit. You found something, you took care of it. Document it. Then getting at the last couple lines, so we can see in this case, we said that there's 100 total backflow preventers that are going to need testing. And in this case, this is your total number in the whole system. It is not necessarily 100 that were due to be tested that year. And then on the last line for J, this is going to be how many did actually get tested. So in this case, when we're looking from the top, like we're saying from C&I, your reinspection frequencies and your testing frequencies might be different. It'd be very convenient if they lined up, but that does not mean they have to be the same. So in this case, all we're seeing is again reported that we had 62 satisfactory. That means the test was completed. It got good results. The assembly's working. And then the last thing I want to point out as we're reaching our time here is again, do not be afraid to use this kind of comment or narrative space. Give us more information. Let us know what was going on. On this slide, we've got a bunch of examples of things that could come up that you're going to want to mention. This is space I at least have not seen used a whole lot, but it's there for you. Please feel free to make use of it. With that, there was a couple last slides here. Again, they're just kind of some commentary, general information things to remind you. So like I said, you can go through this slide set at your own pace. Hopefully it'll just answer some of those troubles that we get when people are trying to fill these out. We understand with some of our forms, they're not the clearest or most direct. So again, this is kind of meant to just help walk you through what are we looking for, how are we expecting to have these filled out. And my last plug before we sign off or take any last questions is, again, if you're not sure, please, again, just feel free to reach out to your district staff, your engineer, potentially the analyst. Part of our job description is to be here available and to help you answer those questions. So if you're not sure, we want to make sure you get it right. We want to make sure we're getting good information. So don't be hesitant to ask. So
All right,
other than
great
that,
job.
Yep, I'll ask if there's any final questions. I know, Matt, you have one last poll.
Yeah,
You would
yeah.
like to give
So I'll
everyone.
go ahead and conduct that final poll question here and get that fired up. And this is the poll question that it looked like some of you were seeing as far as rate this session. You should see a dialog box that has popped up on your screen. And 4 choices: excellent, good, fair, or poor. So please take a moment, rate this session. And that'll be the third and final poll question. As a reminder, you'll receive a follow-up email that'll have some resource information attached to it, and also a link to this recording. So if there are some sections in there that you'd like to go back and brush up on, you'll certainly have that ability to do so. And looks like some of you are not getting full functionality out of the poll. So when this webinar ends, I would just suggest to you that you log into your Zoom client and update it. Make sure that you have the most updated Zoom app available to you, and that should give you full functionality of using this application to participate. So this is our highest response yet. I'm going to go ahead and end it, and that is 98, 99%. Oh my gosh, can we get that one person? So I'm going to go ahead and end the poll question here and share the results. And 50-50 split, that either excellent or good. So Bob and Scott, I want to say great job on presenting today. We will start again at 9 a.m. in the morning. Like I said, you did receive the email this morning that has the links, and that'll allow you to either register or log in the morning for tomorrow's session. So thank you for your time and enjoy the rest of your day.